Hi dear students, in today's video I'm going to discuss about the traffic simulation, why it is required and what are the various steps involved in that. So what is traffic simulation? Traffic simulation, it is nothing but they are computer models which could represent the individual driver behavior and the vehicle performance characteristics, and we can use these models to evaluate any strategies that are dealt with by the traffic engineers. So in order to build these traffic simulation models, we require huge amount of field data like the road geometry, the vehicle characteristics, the volume, the speed, the travel time. So all these data are given as input, and the computer model could emulate what is happening in the field. And using that tool, we can implement what is beneficial for the users, and we can evaluate various strategies. So this plays a very big role, or it's a very big part in the research and development of traffic engineering. As we all know, the new technologies like automated vehicles and interconnected vehicles are emerging. So to test the traffic strategies and evaluate the various traffic management measures, we can use traffic simulation without directly interfering with the real traffic condition. What's the need for traffic simulation? So traffic simulation I already discussed. It has got large variety of applications, and it became an inevitable tool for the analysis and interpretation. So why it is required, or what's the need for that? So certain the same traffic situation we can model it analytically. We can use mathematical model, or we can have an analytical treatment for that. But because of its complex nature, sometimes these are found to be infeasible or inadequate. In those situations, we can come up with traffic simulation models or computer simulation models. Then sometimes if we model a particular condition using the mathematical formulas, then sometimes we may become doubtful about it. Sometimes we may get counterintuitive results. So in these situations, the real traffic can be replicated through the traffic simulation models. And another thing is, say for example, if you are using a intersection, or if you are trying to model an intersection, and sometimes if we are not able to see that, sometimes the mathematical models that we have created might lead to collisions conditions. So this we may not understand unless otherwise we see that on the screen. So when there is animated view of the traffic flow, it's better for us to understand the real traffic condition that is existing there, why this queuing condition is happening, what is the main reason for that, whether all lanes are effectively being used, whether the traffic is moving in the required time. Say we are giving a green to a particular leg, and sometimes the other leg vehicle may be moving. So these situations we can actually see, and we can analyze what is happening, and accordingly we can make some modifications for that. So that is the main the need for traffic simulation. What about the applications of simulation? So the simulation, it can meet a wide range of requirements. Basically, if you consider the traffic simulation, we can actually evaluate, or we can actually analyze the traffic situation existing in field, say by changing the various conditions. Say for example, there is a road. So if you want to make it one way, you cannot directly go and implement it directly on the field. So if we have a simulation platform, we can implement those strategies. So another thing is, if you want to restrict heavy vehicle on a particular road during a particular time, so those things, rather than going to the field and directly implementing it, we can do that by the traffic simulator. So that is the big advantage of traffic simulation. So what are its applications? So evaluating the various alternative treatments. Say as I told, like any problem, we have n number of solutions, or we can have n number of alternatives. Sometimes in a particular intersection, if we want to deal with the intersection, one solution for that is changing the signal time. Another solution is we can provide a high over there. Another solution can be we can restrict certain kind of movements, say right turning, or we can restrict certain kind of vehicles going through that intersection. So there are n number of alternatives available, and in simulation we can actually evaluate the various alternatives without directly interfering with the traffic. So that is one of its application. Another thing is we can test new designs. Say for example, we are going to provide a new router. So what are its design features? How we can vary the design features so that we get the optimum result from that. So we can test new designs. Then it can also be used as an element in the design process, and it can embed with other tools also for effectively studying the traffic. Then we can use this for training the persons. Say for example, we all when going for driving, so for the for learning that, we might have gone through this driving simulator. Hope you remember that. So in a similar way, we can use simulation to train persons, and it can also be used for the safety analysis. Certain situations we cannot replicate that in the real traffic because it is very risky. So those situations or those conditions we can emulate by the traffic simulation. So it can be also used for the traffic safety analysis. So these are the various applications of simulation, traffic simulation basically. Now let's see the classification of traffic simulation. So depending on the level of detailing, we can have basically three classification. One is macroscopic, another is microscopic, and third is mesoscopic. So from the term itself, we'll get an idea about what are these and what's the difference between them. So macroscopic models, they view the traffic flow as a whole, whereas microscopic, it gives attention to the individual units or individual vehicles and their interactions, while the mesoscopic is a midway between this. Mesoscopic models fall in between these two categories. So let's see in detail. Say macroscopic models, it describes the entities and their activities and interactions at a low level of detail, but it represents the traffic stream at the aggregate level. Like it considers the characteristics like speed, flow, and density. So the traffic, it is represented by means of speed, flow, and density, and it's not considering the individual interaction between the various units in the traffic. So that is how the macroscopic simulation is being done, where the level of detailing is less. Then moving on to the microscopic, we are going into the disaggregate level. So the individual vehicles are considered and how it interact with the other vehicle in the traffic stream, and also with the road geometry, and also with the traffic control measures that we provide. So all these interactions are studied in the microscopic model. See, you have studied the car following model, right? So that's an example of microscopic model. Or we can say the lane changing models, or the overtaking models, or gap acceptance models. So we consider how individual vehicles behave in that situation. So we are moving into the disaggregate level. So it describes both the system entities and their interactions at high level of detail in a microscopic model. And next comes the mesoscopic models, which is actually which falls under both these, or which comes in midway between these two categories. So in the case of mesoscopic model, it generally represents most entities at a high level of detail, but describes their activities and interaction at a much lower level of detail. So for example, when running the model, it will be considering the various interactions between the vehicles, but and based on that, it will be giving a result at the macro level. So that is basic difference between the different classification of traffic simulation: macroscopic, microscopic, and mesoscopic. And there can be different criteria for classifying the traffic simulation. The another criteria that is used is how we are monitoring it. Okay, at what interval we are getting the result. So based on that, we can have continuous and discrete. So continuous means we are continuously tracking that, and we are continuously getting the data from the simulation model. So that is uh, continuous traffic simulation. So it requires huge amount of or computational intensity will be high, and we'll be getting a huge amount of output from that, and to manage that is also a little bit complex. So we have to have a proper platform in order to have a user interface with the simulation model. Another one is discrete. Discrete means at certain time intervals we will be getting the output, or we are tracking it at certain time intervals, or when certain events happens. Okay, so this discrete model again can be classified into two, that is discrete time based and discrete event based. So in the case of discrete time based, what we are doing is we are certain fixed time intervals will be decided. So we divide the entire simulation time into certain fixed small intervals, and within each interval the simulation model, it computes the activities and it will give you the result. So that is discrete time based models. Whereas discrete event based means, if certain events happens, then we'll get or we will be tracking it, or we will be getting the output from that. So we can fix, say for example, if queue length exceeds this much, or if traffic congestion, or if the volume exceeds this much. So we can give certain situations, or if some accident or collision happens, then accordingly it will be calculating and giving you the result. So that is discrete event based on certain events. So we can fix the event, so accordingly we will be getting the results. So that is the next type of classification of traffic simulation model into continuous and discrete. The next type of classification is based on the type of processes represented by the model. One is the deterministic model, another one is a stochastic model. So what is the difference between stochastic and deterministic models? So unlike deterministic models that produce the same exact results for a particular set of inputs, stochastic models are the opposite of that. So deterministic model means it will be representing, or it will be producing the same exact result as we give a particular set of input. Whereas in the case of stochastic models, the model presents data and predicts outcomes that account for certain levels of unpredictability or randomness. So the component of randomness or unpredictability is considered in stochastic model. So in the case of deterministic model, I can say all entity interactions, we can define it by some mathematical models, or we can have a logical relationship for the interaction between the entities, and we can use that to simulate a situation. There we are not including any random variables. Whereas in the case of stochastic, we are introducing this randomness, or we are trying to capture this the randomness or unpredictability. So for that we need to introduce probability functions. Okay. Sometimes that event may occur or may not occur. So we have to have a probability function to replicate the randomness in the behavior. The example I can say, like if you are simulating a road traffic, a vehicle flowing on the road, you can simulate that by a simple equation is equal to ut plus half at square, so that it will get updated at each instant of time, which will the position of all the vehicles get updated. That is a very simple kind of doing simulating the traffic. Is a deterministic approach. On the other hand, suddenly one vehicle is changing the lane, or suddenly one vehicle there is a breakdown to the entire system happening. Okay, so there can be overtaking maneuvers performed by another vehicle, or there can be unexpected event like collision or something is happening, or unexpectedly one vehicle is merging into the stream. So if all these situation happens, it may occur or may not occur. So there is a kind of random situation arising there, so which we can model by means of probability functions. So that is stochastic. So the real life condition is modeled by means of stochastic traffic simulations. That is the basic difference between deterministic and stochastic traffic simulation.